Hello, year sixes. How are you doing? Keeping well, I hope. Looking after yourselves and looking after your families too? Yeah? Good. Mr. Morrissey here with our first ever Problem of the Week. Way! How exciting is that? Yes, I'll be making one of these videos every week for the next little while to help you keep up with your maths at home. Hooray! In this video, we're going to be looking at ratios, which is a very interesting, quite a complicated aspect of math. Certainly children I've taught it to before have found it a little bit confusing, a little bit tricky, at least to begin with. But we're going to look at it in a particular way, using a particular language, which will hopefully help us make sense of it and understand it very well. I'll go through a few examples and then I've got some problems for you to do in your own time. Let's get started, shall we? We'll start by looking at this here. I've been making a pattern, and to make the pattern, I've been following a rule. Can you work out what rule I was following? Have a look and have a think. Well, I was doing 2 blue squares and then 1 orange square, 2 blue squares, 1 orange square, 2 blue squares, 1 orange square. That was the rule that I was following. Now we could also use this language to describe the same rule. For every there are That is the language of ratios. And when you're using ratios and thinking about ratios and describing them, I really want you to use the language of ratios. I think it really clarifies what we mean and what we're talking about. So here I would say, for every 2 blue cubes, there's 1 orange cube. For every 2 blue cubes, there's 1 orange cube. Hope you can see that. What about the next example? What about the second bar here? Does that follow a pattern? Does it follow the same rule? Can we use a ratio to describe the relationship between blue and orange cubes there? You can pause here and have a think if you want to. It's actually the same as the first one because there are 6 blue cubes overall, like in the first one, and 3 orange cubes overall, like in the first one. So even though it looks differently, in terms of ratios, in terms of the relationship between how many blue cubes there are and how many orange cubes there are, it is exactly the same. And we can make exactly the same statement using our language of ratios. We can still say, for every 2 blue cubes, there is 1 orange cube. See, we could think of it like this. 2 blue cubes, 1 orange cube. 2 blue cubes, 1 orange cube. 2 blue cubes, 1 orange cube, and there's no more cubes. So we can say for every 2 blue cubes, there is 1 orange cube. The ratio still holds. Now, I hope that makes sense, because now it's over to you. I've got some questions for you to do in your own time and at your own pace, but make sure you're thinking carefully about the language of ratio and how we can identify that relationship between the different items in a set of objects. In the first question, looking at the relationship between the blue flowers and the pink flowers, and we're describing the same ratio in 2 different ways. So the same ratio can be described in 2 or more ways, just like the same fraction can be written in more than one way. So there are many connections, very close connections between ratios and fractions. You should always be looking out for these connections. Use what you know, use what you understand about one aspect of maths to help you understand a different aspect of maths. So use your understanding of fractions to help you understand ratios. In the second one, comparing those yellow cubes and blue cubes, and writing again, it's the same ratio, but in different ways, equivalent ratios. And then for the last one, how many for every sentences can you write to describe these counters? Don't be happy with 1, don't be happy with 2, don't be happy with 3. There are many, many different ones that you could write. Once you've done those, there's some problems for you as well, which should hopefully get you thinking a bit more deeply about ratios. So in the first one, Whitley lays down those tiles in that pattern. Questions for you about that, and then some true or false questions about the red and blue cubes. I'm going to give you the answers to all of these questions very, very soon. So pause the video here if you still need to go through them by yourself. Let's look at the first 3 questions. So in the first one, for every 2 blue flowers, there are 4 pink flowers. for every blue flower, there were 2 pink flowers. Second one, for the cubes, you could say for every 2 yellow cubes, there's 1 blue cube. Or for every 16 yellow cubes, there's 8 blue cubes. And there might be alternatives as well that you found. Next one, for every 8 yellow cubes, there are 4 blue cubes. And for every 1 blue cube, there were 2 yellow cubes. And I suppose what's more important here is seeing how they are all the same. They're equivalent ratios. Why is that the case? And then for the last one, well, there's quite a lot of possible answers. Let's go through a few. So if there's 15 yellow counters, 5 blue counters, and 3 red counters, what can we say? Well, for every 15 yellow counters, there are 5 blue counters. That's a pretty obvious one. But then an equivalent ratio that maybe you spotted was for every 3 yellow cubes, there is 1 blue cube. And let's compare the yellows and the reds. So for every 15 yellow counters, there's 3 red counters. That's exactly the same as saying for every 5 yellow counters, there's 1 red counter. And of course, you can do the opposite way around. For every 1 red counter, there's 5 yellow counters. And then here are some answers, or some possible answers for the 2 problems. I hope you got on well with those. Well, that's it for this video. I hope you enjoyed the lesson, and I hope you feel that you understand ratios a little bit more than you did before. I'll see you next week for another problem of the week. In the meantime, take care, look after yourself, look after your families. Okay, bye.